Hello, Mr. Carter. This is quiz 39, David Engell. And the first one asks for the velocity, the recoil velocity of the cannon. So to do this, we'll solve with conservation of momentum. It starts at rest, so 0 is equal to mc vc plus mcb plus vcb. And so when you solve, you're going to find that VC equals negative MCB VCB over MC. Hooray! So that's for part A. For part B, the real fun starts, and you have to solve for the kinetic energy of the cannon in terms of kinetic energy of the cannonball. Kinetic energy of the cannonball is going to be 1/2 mcb vcb squared, and you're going to multiply that by the ratio of the masses, so it's going to be mcb over mc, and that's going to be equal to kcb. So in nice terms, it's going to be kcb times mcb over mc is equal to kc. Hooray! Number 2, again, conservation of momentum. First part of the question is just m1 v1 equals m1 plus m2. They stick together. It's nice, and they stick together, and it's sweet. So that's really easy because you just swing that over, and v2 is going to be m1 v1 over the sum of the masses, m1 plus m2. That's going to be part A. Hooray, done! This is part B. Again, same principle that the kinetic energy of one of the carts is going to be 1/2 m1 v1 squared. That's going to be the kinetic energy of that first cart. And then, again, you're going to multiply that by the ratio of the masses, and that's going to be m1 over m1 plus m2. It's the two combined masses. So again, that's going to be equal to k, the whole thing. And then, again, in nice terms, k is equal to the kinetic energy of that first times the ratio of the masses, which is mass 1 over the sum of mass 1 plus mass 2. And that is 2. Number 3, again, conservation of momentum. What a huge surprise. A is going to be m1 v1 plus m2 v2 equals the sum of the masses, m1 plus m2 times v2. And to solve for v2, simple, just a couple swings over. m1 v1 plus m2 v2 over the sum of the masses, m1 plus m2. That's going to be a v2. That's going to be part A. Part B is going to be the sum of the change in kinetic energy is going to be the kinetic energy final minus the kinetic energy initial. And what that's going to be is the kinetic energy final is going to be the masses, 1/2 sum of the masses, m1 plus m2, times the velocity of the two masses, which we just found over here. And we can rewrite that, m1 v1 plus m2 v2 over m1 plus m2. And that whole quantity is squared, 1/2 mv squared, basically 1/2 mv squared. And that is going to be, you're going to subtract the initial kinetic energy of your system, which was just 1/2 m1 v1 squared plus 1/2 m2 v2 squared. And if you want to solve that out, that's going to be equal to the change in kinetic energy right there. That's your final minus your initial. The next is going to be the impulse of this graph, force and time. It's going to be the area. So if we fill in this, we discussed the fact that if you like swing this over, it's going to be looking like this, and this is basically going to be the area of your nice little curve there. So it's going to be 4. And impulse J is equal to the change of momentum, so again it's going to be 4. And the velocity of the cart as it leaves the spring, it comes in at negative, or well, it leaves at hold on, sorry, my bad. The momentum is going to be mass times velocity, which is going to be -2, so that's going to be initial momentum, and then it changes by 4, so you're going to add 4 and divide that by the total mass, which is going to be 2, and when you do that, it's just going to be 2/2, and I need my calculator for this one. 2/2 is, oh, it appears to be 1, so it's going to be 1. Again, this one, you can laugh at me for doing it this way, but it's going to be the integral under this, and that's just going to be a nice trapezoid. At 0, it's going to be 6. At 1, 2, it's going to be 12. So if you take 1/2 your base 1 plus your base 2, multiply by the distance between them, it's going to be 18. So again, your A is going to be 18. Your B, again, the J is going to be equal to the change in momentum. So again, your change in momentum is going to be the same as your impulse, which is going to be 18. And your initial momentum is going to be this 2 times 6, which is going to be 12. And the change in momentum is a positive 18. So again, divide by your total mass, which is 6. It's going to be 30 divided by 6. Again, a bit of a calculator solver on this one. It'll just be a second. Hold on. Gotta get it into like trig form and create crazy, 5 times a dollar craziness, and 30 divided by 6. It's telling me it's 5. I'm gonna go with 5 on this one. So we have 18, 18, 5, 4, 4, and 1. So that right there, pretty long one, but what are you gonna do? 6 questions. That is going to be your quiz number 39. David Engell.